Subscribe กดติดตามกดกระดิ่ง
เมื่อวันที่ 4 มกราคม 2023 ที่งาน CES NVIDIA ประกาศว่าได้เซ็นสัญญากับฮอนไห่ MIS เพื่อมอบความไว้วางใจให้ฮอนไห่ผลิตคอมพิวเตอร์ไร้คนขับโดยใช้แพลตฟอร์ม
NVIDIA Drive Print
สถาปัตยกรรมไร้ HY
Drive Victorian
และจะจัดหาผู้ผลิตพันธมิตรของฮอนไห่ MIS ปตท. ยูลอนไต้หวันโรงงานของอเมริกา
Lordstown
และ
Monarch Tractor Fisker Automobile Company
เป็นระบบที่ดีที่สุดในโลกดีกว่าของเทสลาหลายสิบเท่า
Last year, we introduced Atlan, a 1,000 TOPS SoC. Today, we're announcing that Atlan is no more and will be replaced by Thor, twice the throughput of Atlan and more than twice the delivered performance. There are three big reasons we did that: Grace, Hopper, and Ada Lovelace. The incredible transformer engine of Hopper and the fast evolution of vision transformers is too important not to include in our next robotics processor. The invention of multi-instance GPU in Ada is a great opportunity to centralize the car computer, reducing hundreds of dollars of cost. And the CPU of Grace is too amazing to pass up. As all parallel processing algorithms are offloaded and accelerated by our GPU, the remaining workload tends to be single-threaded limited. Grace has excellent single-threaded performance. So engineers at NVIDIA scrambled to create Thor. The amount of new technology in Thor is insane. Thor can be configured in multiple ways, can dedicate all of its 2,000 TOPS and 2,000 teraflops to an autonomous driving pipeline. Or it can be configured to use a portion for cabin AI and infotainment and a portion for driver assistance. Thor's multi-compute domain isolation lets concurrent time-critical processes run without interruption. On one computer, you can simultaneously run Linux, QNX, and Android. Thor centralizes numerous computers and simultaneously offers a leap in capability while reducing cost and power. Today, parking, active safety, driver monitoring, camera mirrors, cluster, and infotainment are different computers. In the future, these functions will no longer be separate computers, but will be delivered by software that runs on Thor and improves over time. Building robotic computers requires two computers. An AI factory in the data center that processes data, trains the AI, simulates the digital twin, and maps the world. And an AI computer in the car that processes the sensors to perceive the environment, stay clear of obstacles, and drive the car to its destination. NVIDIA Drive is an end-to-end platform for autonomous vehicle development and deployment. For development, Drive includes Replicator synthetic data generation, NVIDIA AI infrastructure, DriveSim, and DriveMap. For deployment, Drive includes the full-stack driving and in-cabin AI applications, the AI computer, and the Hyperion Reference Autonomous Vehicle System. Let me show you some of the new exciting capabilities in the NVIDIA Drive platform. First, an AI pipeline called Neural Reconstruction Engine that came out of NVIDIA research is now a major feature in DriveSim. Creating scenarios for simulation is laborious and difficult to scale. Our researchers have developed an AI pipeline that constructs a 3D scene from recorded sensor data. The 3D scene is imported into DriveSim and can be augmented with human-created content or AI-generated content. This video to 3D geometry pipeline runs on NVIDIA OVX systems and enables us to create simulation scenarios on a global scale. Let's take a look.
We are supercharging DriveSim with a neural reconstruction engine to enhance simulation with AI and data captured by the fleet. In a matter of minutes, the neural reconstruction engine can reconstruct a full 3D digital twin of a recorded drive from sensor data. Objects are harvested and reconstructed using AI. Large-scale asset and scene libraries are created from real-world drives. The reconstructed scenes and assets are loaded into Omniverse and are ready to use in DriveSim. Using NVIDIA DriveMap, we can place dynamic objects such as vehicles, as well as pedestrians. Recorded data can now be turned into fully reactive and modifiable simulation environments for closed-loop testing. New scenarios can be authored using synthetic and harvested scenes and assets. We can generate synthetic ground truth data to train perception networks. These authored scenarios can be used for end-to-end testing, including challenging scenarios. NVIDIA DriveSim, powered by Omniverse and AI.
DriveSim is essential to building our driving system from beginning to fleet operations. It's an integral part of our CI/CD, continuous integration, continuous deployment engineering process. One of the most important DriveSim features is hardware in the loop, which lets us run the entire in-car software stack right there in the AI factory. The AI car computer has no idea it's actually inside a simulation and not in the car and driving on the road. DriveSim, with hardware in the loop, can also simulate the inside of the car. Future cars will not just have simple dashboards, but surround displays where digital and physical design come together. Car designers, software engineers, and electronics engineers can collaborate in DriveSim while running all the actual computers and software stacks. DriveSim will be their virtual design studio. Let me show it to you.
We are extending NVIDIA DriveSim's platform to create a digital twin of the car's interior with full hardware-in-the-loop support. NVIDIA Omniverse is the platform that brings this all together. Designers and engineers can work side by side to perfectly integrate the physical design with the digital interface before the actual car exists.
Let's try new cluster layout.
Sure.
Can you resize the screen?
Okay. Let's try this.
This looks good.
Drive Sim, built on Omniverse, will accelerate the development of new AI cockpit and in-vehicle infotainment systems, plus improve usability by testing them in a digital twin of future cars.
Safety is the #1 priority in robotics. And as I mentioned, building robotic systems requires building 2 computers, an AI factory in the data center and an AI computer in the car. Safety architecture, design, and methodologies are pervasive throughout our systems from data center to the car. NVIDIA has invested 15,000 engineer years in safety systems and processes. 5 million lines of code have been safety assessed. Our drive chips and platforms are designed for ASIL-D operation and ISO 26262 safety. We've dedicated ourselves to an end-to-end safety approach that extends from the AI factory to the fleet. We're making excellent progress developing the Drive end-to-end autonomous driving system. Let me show you our progress. From replicator synthetic data generation to AI model advances, Drive Sim with hardware in the loop, Drive Map autonomous fleet mapping, urban and highway driving and parking. Let's take a look.
Hi Pavithra, you have an event at Plaza de Cesar Chavez Park at 6 p.m. Would you like me to navigate there?
Yes, please.
Beginning drive pilot. You have arrived.
Robotic computers are the newest type of computers. These are real-time systems that sense the environment, reason about their surroundings, and plan actions consistent with their goals. Orin is our second-generation processor designed specifically for robotics, and it is a home run. Orin is the computing engine of autonomous vehicles and has been selected by over 40 companies building cars, trucks, robotaxis, and shuttles. The fundamental processing pipeline for autonomous vehicles can be applied to all kinds of robotic systems. Jetson is our robotics computer with 1 million developers and used by some 6,000 companies, including 1,000 startups. Amazon, Boeing, Canon, Microsoft, Shopify, and Teradyne are among the many companies building robots with Jetson. We're working with the industry on amazing robots, from pick and pack robotic arms to agriculture robots, AMR autonomous mobile robots, to last mile delivery robots. Today,